So for the following problem, we want to solve triangle ABC given angle A is 32 degrees, angle B is 85.2 degrees, and side A is 42.9 meters, where approximation is allowed. So one thing to note on these problems is whenever you're going through them, if you get to the point that you can no longer use the given information to solve the problem, then you are allowed to use the approximated values that you've found along the way to find the complete answer. If you can use given information though, so that you don't have to introduce this rounding error, then you should. And in general, you are supposed to use the actual answer and not the approximated values. But for my teaching, I find it okay to allow this little bit of rounding error for problems like this where you have no other choice than to introduce a complicated method using your calculator. So with that in mind, for these problems, feel free to approximate if the given information stops allowing you to solve the problem. So from there, to solve this triangle, we're looking for the values A, B, and C for our angles and A, B, and C for the sides. And we were told angle A is 32 degrees, angle B is 85.2 degrees, and side A is 42.9 meters. So we're looking for angle C, side B, and side C. With that, we'll go ahead and create an example here. We have angle A, angle B, and angle C. So we'll plug in 32 for A, 85.2 for B. We don't know C, but we know side A is 42.9. So notice we were given a side with an adjacent angle and then the following angle. So that's side, angle, angle, or angle, angle, side, however you want to look at it. Either way, we can solve this using law of sines. And the way we'll go about that is the first thing we need to do is find our third angle. Remember, if you take angle A, add angle B, and add angle C all together, the result has to equal 180 degrees because this is a triangle. All triangles add up to 180 degrees when you take all three of their angles. So that means 32 degrees for angle A plus 85.2 degrees for angle B plus angle C is equal to 180 degrees. So if we subtract 32 degrees from each side and then subtract 85.2 degrees from each side, we'll be left with angle C is equal to 62.8 degrees. And now that we have that, we can plug that in to our solution, leaving us with just side B and side C to solve for. And now the law of sines will come into play. And there is a choice here whether we want to go for side B or side C. So there's an important note to make here. When you're solving for the angles based on the sides, you always want to start with the smaller side first, because the larger side could have an angle that is obtuse. Remember, when you solve for sine, sine is positive in quadrant 1 and in quadrant 2. So there could be an angle in quadrant 1 or in quadrant 2 that solves the problem. Meaning you could have an angle of 60 degrees as your answer or an angle of 120 degrees as the answer. But if you solve for the smaller angle first, then you'll know which of these two for sure is the actual angle in your triangle. So why am I saying that right now if we already have all three of our angles and we don't need to worry about that? Well, it's generally a good idea to stick with that same method always so that you don't forget to use it. Meaning, we should probably start by solving for side C first. Since it has the smaller angle, we want to deal with the smaller side or smaller angle first, always. This way we don't accidentally ever use the larger side and solve for the larger angle first, which could introduce this problem where we end up with two solutions and we'll have to decide which one is correct. So again, although it won't end up affecting this problem, let's go ahead and start with the smaller one first. We're solving for side C using the law of sines. So we're going to use C over sine of C, but we know angle C is 62.8 degrees, is equal to, and we can't use side B and angle B because we don't know side B, so we'll use A and angle A. So we get is equal to A is 42.9 over sine of A is 32 degrees. To solve for side C, we'll multiply each side of the equation by sine of 62.8 degrees over 1. And when we do that, on the left side when it gets multiplied, it's just going to cancel out the denominator. And on the right side, we can multiply straight across, which gives us C equals 42.9 times sine of 62.8 degrees over sine of 32 degrees. And now this is something that we can plug right into the calculator. And when you do, in fact, I'm just going to write this over here. Once you plug that into your calculator, remembering to use degree, the degree function on your calculator. So if you're using a TI-83, TI-84, TI-Nspire, anything like that, you hit mode on your calculator and it'll say radian or degree. Select degree because we're using degrees as our angles. And when you do, you get C equals 72.0034 meters. We always want to round to 4 decimal places unless otherwise specified, or if it doesn't make sense, like when you're dealing with money, in which case you would round to 2, for instance. Okay, so now with that, we now have side C. Now let's solve for side B. So side B is going to be the same thing. We have B over sine of B is sine of 85.2 degrees is equal to, and now we have to decide, do we need to use this C over sine of C? Because if we do, we will introduce rounding error. Notice in this problem, we do not have to use the value we just solved for because we already have given information that will satisfy what we need to do here. We can use A over sine of A, so 42.9 over sine of 32 degrees. We're going to solve for B just like we solved for C. We'll multiply each side by sine of 85.2 degrees over 1. It's going to cancel out on the left, and on the right, we'll just multiply straight across, which gives us B equals 42.9 times sine of 85.2 degrees over sine of 32 degrees. And when you plug this into your calculator, you should get 80.6718 meters. And these are all three angles and all three sides of the triangle that has the following given information. A equals 32 degrees, B equals 85.2 degrees, and side A equals 42.9 meters. So this problem is completely solved.